Are we alone in the universe? An age-old question that has echoed throughout history. But is it a question we are now on the cusp of answering with the technological capabilities we have around us? Dimethyl sulfide on Earth is primarily produced by phytoplankton and only by biological processes. So when the James Webb Space Telescope detected its presence on exoplanet K2-18b in 2023, it grabbed worldwide attention. Had we finally found life beyond Earth? As it turned out, not yet. The scientists are approaching this find with extreme caution, stressing the need for further analysis and confirmation from the James Webb Space Telescope before drawing any definitive conclusions. So currently, the preliminary evidence comes with no claims of discovering life on another planet. But let's suppose it turns out that we have found life. What type of life could it be? This would certainly be a historical moment in our search for life, but as this is only a biosignature indicating biological activity, we'll be none the wiser as to whether the planet harbours intelligent life. For this we'll need a technosignature, a marker that indicates the existence of advanced technologies that only exist because an alien intelligence is behind them. To help us do this, in the 1960s, Soviet astronomer Nikolai Kardashev introduced the groundbreaking scale to measure a civilisation's level of technological capability based on its ability to harness and utilise energy. This scale has three distinct categories, giving us a foundational framework in our search for extraterrestrial intelligence, beginning with a Type 1 civilization. Type 1 civilizations are known as planetary civilizations and have reached a stage where they've mastered the resources and energy available to them on their home planet. To put this scale in perspective, we're still a pre-Type 1 civilization, hovering around 0.73 on the scale. Type 1 civilizations, though, boast advanced technologies tailored to harnessing their planet's energy, which, like our technologies, may emit wastes in the form of pollution that ends up in their atmosphere. Just as we scrutinise potential biosignatures on distant exoplanets like K2-18b, utilising the James Webb Space Telescope, a similar methodology can be applied to identify indications of pollution within a planet's atmosphere. The James Webb Space Telescope employs a technique known as transmission spectroscopy, which involves examining an exoplanet's atmospheric composition by analysing the light passing through it. To illustrate, imagine observing a rainbow on a bright, rainy day, where raindrops split visible light into its constituent wavelengths, giving us the spectrum of 7 distinct colours we see. However, if this light traverses through a planet's atmosphere before reaching our instruments, certain wavelengths may be absorbed by molecules present within the exoplanet's atmosphere. Consequently, the observed rainbow might be missing orange, and if we know which molecules absorb the wavelength corresponding to orange light, we can work out the composition of molecules within an exoplanet's atmosphere. For example, the absence of certain wavelengths of light might suggest the presence of chemicals like CFCs. If this were found in an exoplanet's atmosphere, we would have our technosignature, as this chemical is only produced by industrial activities, and it strongly suggests the existence of intelligent life on the planet. But would there be any technosignatures that may indicate this could be from a Type 2 or even a Type 3 civilization? A Type 2 civilization is often labelled a stellar civilization. They possess the capability to harness the energy output of an entire star, where the technology they use to do this may leave detectable traces, giving us a technosignature indicating intelligent life. In fact, we thought we had discovered such activity in 2011 around a star called KIC 8462852, later named Tabby star. Normally, when an exoplanet passes in front of its parent star, the light dims by about 1%. So when the Kepler telescope observed Tabby star dimming by as much as 20% and doing so in an irregular pattern that is uncharacteristic of an orbiting exoplanet, scientists knew they were witnessing something extraordinary. Speculation as to the cause led to the serious consideration this could be a techno signature from a Type 2 civilization. The idea was that a technologically advanced civilization was constructing a colossal structure known as a Dyson sphere around the star that would harness its energy. Further study and analysis have since provided alternative explanations for the observed dimming, where in this case scientific evidence is pointing to a natural phenomena, such as dust clouds or cometary fragments that are passing in front of Tabby's star. Currently, the idea of harnessing the entirety of a star's energy output may surpass our technological capability, but given enough time, a civilization will push their technological boundaries to such an extent where they develop godlike technologies that harness the energy of an entire galaxy. These Type 3 civilizations, also known as galactic civilizations, would likely have megastructures throughout the galaxy, harvesting energy on a colossal scale. They would produce immense amounts of waste heat in the process, and their galaxies should be lighting up with the excess infrared radiation. And if we can see that, we have a techno signature. So when the glimpsing heat from alien technologies survey started, utilizing technologies such as NASA's Wide Field Infrared Survey Explorer, millions of galaxies were surveyed to see how many had excess infrared radiation. Of the 100 million surveyed, 100,000 candidate galaxies were found with excess infrared radiation. Similar to the approach taken with the potential detection of biosignatures on K218b, the scientific community exercised caution when interpreting these findings, where further analysis found the excess infrared radiation was consistent with star formations in dusty galaxies. Our search goes on for the moment then, but one thing is clear: it seems the technological capabilities we have around us has finally caught up with our aspiration to answer the age-old question: are we alone in the universe?